what we are going to do, as I talked about it the other day, we are going to give you the introduction to the notion of the functions, because we need the function to be able to do the calculus, okay? So I'm going to review section 1.1.2. Probably you are familiar with this concept, but it's going to be very important. So we're going to tell you or to show you what you need to know, okay? So a brief description of the functions. You know that the easiest or the quickest way to talk about the function is consider the function as a machine. So this machine would accept a variable, okay, x. This is going to be the machine. So we are going to pick an x is a free agent. We call it an input. Okay, there's going to be the input. And we drop it into the function machine. Okay, this is going to be the function machine. This machine, the action of the machine is the one that we are going to define. It's a mathematical machine. So this machine can do adding, subtracting, multiplying, dividing, taking the square root, cube root, okay, finding the sine, cosine, tangent, etc. So we give the x to the machine. The machine would operate on the x. So the action on the x is going to be resulted as f of x. This means the action of the machine on the x. It depends what type of instruction do you have. Okay, so this last result is going to be called output. So this is going to be output that we usually denoted by y. So basically, this is the notion of the function. So a function is a mathematical machine. You give something to the machine and you will get something out. There is only one condition. The condition is the function would match each x to only one y. So for each input, you are going to get only one output. You cannot have two outputs. Okay, so that's the definition of a function. And it's all over the places. Your calculator is a machine, is a function. So you are going to drop the x, it depends. If you click on the square root, the calculator will give you a square root of x. If you click on the sign, the calculator will give you the sine x. All the cashiers are going to be functions. Okay, so officially, this is going to be definition. So a function, a function f is going to be, is a relation. Okay, is a relation. Maybe it's defined by an equation. Okay, relation, an equation. You may define it by a formula. Okay, by a formula. Or you may define it by a table. Okay, a table. Or you may define it by a chart. Or okay, or a chart. It depends on the application. Okay, that, now the action. That relates each given input. Each given, okay, input x, whatever x is. Okay, so each given input to one and only one, to exactly one. Output, it matches with, with the y if you like. Output y. Okay, so this is what we are going to have. So you give the x to the machine would bring a y and match them together. So in that case, you are going to have a function. Now this y is going to be denoted by, y is the action of the machine, is denoted by f of x, and y equal to the f of x is going to be called the equation of the function. It's called the equation of the function. So that is going to be a short version of the definition of a function. This is the type that we accept in, we use in calculus. If you are a computer science major, you are going to have a course discrete mathematics. In discrete mathematics, you like the function to be defined by an order pairs. And, but in calculus, we are going to have for working with this type of the equation. So that's why we are not going to bothering to get into those type of ideas. Okay, any question? So let's have some examples. Examples first, examples from everyday life. Okay, some example from everyday life. I just give you the hint. The first one is your calculator. Okay, your calculator is a function, is a multi-job function, if you like. Okay, how this machine is operating with your calculator. You see, this is the X, a number. So what do you want to do with this number? You may be interested to take the square root of this number. So what you do in your calculator, you are going to click on the square root. So the machine would give you what? The machine would give you the square root of X. Okay, so this is going to be your output. Y equal to the radical X. You know that this is called a square root function. Okay, so this is the square root function. Okay, so your machine is the square root in this case. Any question? So for example, if you start with a 9, and if you click on the square root function machine, so the result would be what? The result would be the square root of 9 equal to 3. So the function matched the 9 to the 3 for you. So this is going to be a square root function. Any question? Suppose we try, let's try -4. If you try the -4 with this machine, and if you click on the square root with your calculator, what's going to be the result if you're using your calculator? Any suggestion?
It would be no solution.
Yes, or what is exactly the output of the calculator? We need that expression that you will see.
Domain error.
No, exact calculator result. I know what you're talking about. If you check your calculator, the calculator will give us what? Error. That's what you see in your calculator. What is the reason? Yes, you are right. The reason is, you know that radical -4 is what? Is not a real number. It's not a real number. Okay, so this means -4 cannot go through the machine. If the number can go through the machine, we say that number is in the domain of the function. So in this case, the -4 is not in the domain of your function, because the square root is, the square root of a positive numbers. Okay, that makes sense. No complex numbers in calculus, remember. You have to take calculus 1, 2, 3 first, then come back. Then come back and start with working with the complex numbers. So in this course, no complex numbers, okay? We work with the real numbers only. So you know the idea that that give you the error because the -4 is not in the domain of the function. We are going to define the domain in a minute. Okay, so the number, if the number is going through the machine, that's nice. Is in the domain of the function. So this means your machine can operate on X. If the machine cannot operate on any number, this means this number is out of your domain. Okay, that's one. Any question? You know that you can have various functions in your calculator. You can start with the X. Then you may click on what? Sign. If you click on the sign, So the result would be what? Sine x. So you get y equal to the sine x. You know that y equal to the sine x is the sine function. Okay, it is going to be the sine function. So the calculator is very nice machine that give you a good understanding of what's going on with this type of ideas. Any question? Give us example from everyday life. Examples of function.
Vending machine.
Vending machine. Vending machine is a very good one because it's going to be piecewise defined function. Yes, very nice one. You know that they ask for you, you select, you pay, the vending machine will give you a bottle of soda. Yes, very good. Any more in everyday life? Function, everyday life.
Your cell phone.
Very good one. Yes, your cell phone is a good one for calculus because you have a contract of $65. For example, today is unlimited. You have a contract for 700 units, you pay $65. But if you go over it, you know that they charge you differently. So that would be very nice function because we have to use different formulas. Yes, cell phone, piecewise defined function, the popular for calculus. More in everyday life.
What about for like a car? Like you put in 2 gallons of gasoline and you're gonna get like 40 miles.
That's it. Excellent. Yes. Gas. To get to the gas station, X is you select, when you go to gas station, you select X is the number of the gallons, for example, that you want. Then you select, okay, the machine would run, but they charge you. Okay. It depends which type of the gas you selected, type 1, type 2, type 3. And it's a very good machine because you will see the money. Okay, $5, $10, etc. So the gas station is very nice function. As soon as you start X, Y, money. You know that sometimes you go to the cashier, so $20 on one. So you just select how much you are expecting to have. So gas station. Okay, more.
What about a computer?
Yes, computer is a good one because you put the input, whatever you like, okay, and you get the result. Like the ATM machine. ATM, you select, they ask it. X, they search, they give the money. Okay, more examples. There are a couple of nice ones that you missed.
A toy capsule machine.
Which one?
The toy capsule, you put in a quarter and you get a little toy.
Yes, all those cashier type machines are functions, okay? All the cashiers. What the cashier do, you scan the item. You scan the item, the machine will bring the soda function. They charge you, ding. Then then you go to the chips, the machine will bring, the chips machines, if you like, ding, they charge you. So all the cashiers are functions. Okay, more functions, everyday life. Just think about it. Where do you go? What do you do? Whatever you do.
What about a Netflix subscription?
Netflix subscription? Yes.
What about like the temperature or like
the temperature and what?
Like if it's like 2 p.m. then it'll be like, I don't know, like 80 degrees during that time. I don't know.
Okay. Very big function. Okay, more. Yeah, you have to define your input and output. Yeah, I mean the machine that determines the temperature is a function, if we can say that. Okay, that's fine. Okay, more examples.
Arcade machines.
Which machine?
Arcade machines.
Okay, what type of machine is that one? Explain the input output.
Like at Dave and Buster's,
Oh, those
arcade.
Yeah, okay, yeah. Okay, very good one. More. Be quick, give us those nice one for calculus. How about the Starbucks? Starbucks is a nice function. The menu of the Starbucks is a function. You see, it's a nice function because in the Starbucks, the function is finite. On one side, the excess, the inputs are given to you. White mocha, cappuccino, that. On the other side, the money. Okay, so the inputs are names, output, the money that you pay. When you go to the cashier, you see, you say, oh, I want white mocha. She just click the white mocha and charge you $4.75, etc. So the Starbucks is the menu of the Starbucks is a nice function. This is the function that's defined by a chart. Remember, we talked about it, the chart. You get the chart of the names and the money. The cashier would calculate it for you, and that give you the money. Okay, so all these type of the, okay, all these type of the machines are going to be functions. So a Starbucks is a function. You go to all the fast food restaurants. As soon as you arrive, you see the menu. You go to Burger King. You see the menu, what's that? The waffle, King Burger, etc. So the money. And as soon as you go to the cashier, you know that sometimes they have the picture, Big Mac, that, they charge you. So that machine inside the cashier is the function. It's a multi-job function, if you like. And the formula is already given, so we can use it. Yes, remote control is going to be a function. So the Starbucks, okay, all grocery stores are all functions, Macy's, cashiers, etc. functions. Any more?
Would a job count?
Would a movie theater be considered a function?
Which, I didn't get that. Again. Okay.
Go ahead, whoever said the other one. I didn't mean to cut you off.
That's all good. I said a job because you put in like work and hours and you get out money, your salary.
Yeah, your payroll is a function. Yes, it's a very nice function because the formula is already there. So you go there, oh, this is me. They just give you how many hours you work, how much is going to be paid for you. Yes, very good, man. Yes. Now, a couple of them that can be very interesting for calculus is going to be this, the one. What do you do in April 15? Of course, if you work. April 15? So we haven't paid your taxes. You don't know that. Okay, April 15, you file the tax return. The tax return is very nice function. You see the tax return, that's a very nice example for calculus. Okay, so we call it number 2, tax. Okay, tax function, let's call it. Why we like this one for calculus? Because this is the function that cannot be defined by one equation. You need several equations. Why? You see, for the tax, X is going to be your income. So when you want to calculate your taxes, okay, so what is going to be T of X? Depends on X. If your income is going to be between 0, let's say, and I don't know, 30,000. So your tax would be about 10%. It's going to be 10% of your income. So it's going to be 10% of X. But if you make more money, okay, something like, let's say $100,000. So your tax bracket would be different. So the formula that the machine is going to be using, let's say, 15%. And it just keep going. Okay, it's going. So you get to the situation that your income, if your income is less than, bigger than, let's say, $400,000. So this is going to be the maximum, something like 35% of X. You see, at the beginning, they didn't believe that this type of expression is a function in history of calculus, because they believed that the function must be defined by one equation only. But this is several equations. They didn't like it, they didn't believe it, but it was physics, the phenomena in physics that forced them. Because in science, what we do, that we do things at different phases, different brackets. So that's why they have to talk about this type of function. So this type of function are going to be, so this is going to be called the T of X, if you like, is going to be a piecewise defined function. Piecewise defined function. And we have to look at it before we're starting our things, if you like. So all the function, almost all of them, that you are going to use in physics, chemistry, biology, okay, business. They are all piecewise defined function. So we are going to pay attention to this type of functions. Okay, so the tax function is, your cell phone is the same thing. Your cell phone function is the same thing because you have a contract, you have the limit if you like. Okay, so this is very nice example. And I give another one, very similar one that we're going to use. Okay, you know, this is similar to the post office function, we call it. Okay, post office. Post office function. Post office function is the same thing. You know that when you go to the post office, you want to post something. So what you do, you put it in the scale. So the scale will give you the, you know, the that result. Okay, so for example, you know, it's going to be, let's call it S of X, the scaling one. So if your parcel is going to be something like between 0 and let's say 5 ounces. Okay, so how much to pay? You know, we pay something like 43 cents. So it's going to be $0.43 if you like. But if you have something which is going to be heavier, okay, it's going to be heavier, let's say, you know, 20 ounce, then you have to pay more, let's say $1.50, and then it's continue. So the post office function is again a very nice one. You know that in the old days, they used to look at the booklet, you know, the cashier, they'll open up the booklet and they tell you how much it costs you. But today, they just use a machine, use the computer. Okay, so again, it's a piecewise defined function of this group. We like it. We are going to use it quite a lot. Any question? And the other one is if you pay your utilities, that's the best function. You see, water, gas, electricity. If you have your bill, you can have a look at it. They explain it to you. They say, oh, be careful. The more you consume, it's going to be more expensive to pay for it. So they show you a chart. You see, they show you the chart that how they are going to, okay, so that's going to be utility. Utilities, I think that's it, the utilities. Okay, the utilities one, you see, this is going to be, you know, gas, electricity, water. Okay, and so for example, if you want to, you know, you consider the electricity one. So when they want to charge you, depends on the X, how many kilowatts, okay, how many kilowatts you consume. So if your X is going to be between 0 and let's say, I think it's 200, 300, 200 kilowatt. Okay, they are going to charge you something like, you know, let's say 30 cents per kilowatts. So the formula that you are going to be charged is going to be this one. But they warn you, oh, if you go over, okay, if you go to the next bracket, if you go to the next bracket, they are going to charge you, let's say 70 cents for, and then if you go to the higher one, they are going to charge you quite a lot. Okay, they may charge you something like 1.2x. So utilities are going to be the best functions that we're going to, for calculus, these are the ones that we are going to use, okay? And this is, you know, it took mathematicians something like 50 years really. They didn't accept it because they were working on just curves and not the function. They believe an equation in X and Y, that's it. But an equation in X and Y, they used to call it curve rather than the function. But this is the modern format of the function, okay? So I would like you, before getting to the X, Y, Z, just feel it around, you know, what's one? Calculus is a dynamic course. Anything you do in this course, various applications. So just look for those applications, compare, that give you a better understanding of the concept, and you enjoyed it. You see that you are doing something, you know, something useful. And we are going to have quite a lot of this. Okay, any question? Now we get back to the, you know, to the abstract one, you know, what's polynomials, rational functions, radical functions, to take care of it. But then we get back to these ideas again. And so what we need to know is we need to know the domain and the range function. Okay, mostly the domain that we are going to be interested in. So we check that one too. Question. So get a good feeling of the function. And don't be disappointed if you have some difficulty about it. And don't worry, there are various ways to do it. If you search on internet the concept of a function, you'll be surprised how many items you can find. They give you different stories, about the function. So this is the definition of a function, but we are going to be interested in mostly really at this time, what is the domain and the range function? Mostly the domain, so I'll give you the definition of both of them. So what's going to be the domain? And that would end up with the first question on the quiz and test of this section, the domain and the range. And the range of the function Okay, we talk about the function is the relationship between the inputs and the outputs. You see, when we say x is, we call it a real variable. Real variable means x stands for any real numbers. But when you want to get the x as the input of a function, you may have some restriction. If that x or the value of the x can go through the function and find the y to match, this x is in the domain of the function. So the set of all, let's get the definition. You see, if y equal to the f of x, okay, is given to, is a given function. Okay, so the equation is given. Then the set of all, okay, all inputs, okay, or x values is the domain, and the resulted one. Okay, and the resulted outputs, okay, outputs or y values is going to be, is the range of the function f. You see, that's a definition of the domain and the range. Again, if you are a computer science major, you are going to have something we call it domain and the codomain, and between the range, but we just stay with these two expressions. We are not going to use the expression codomain. Even in that field, again, they usually drop it. Okay, so this is going to be your job. If the function is given to you, then you should be able to determine the domain of the function for us. There are a set of functions that are going to be our tools from now on. So we are going to introduce those functions, and we want to make sure that you are ready to find the domain of those functions for us, okay? All of them are going to be given through the course. In quiz 1 and the test 1, you will see them indirectly in 3 questions. So pay attention, and this is going to be your first serious job in this course. Okay, so very important example for this course. I know that you know it, but we want to make sure that you are ready for it. So find the domain of each function. We're going to be interested in the domain. The range we need more to be involved, but we don't need it for the time being. So find the domain of each function. Okay, various groups that we are going to use. The first one is this function, f of x equal to the x to the 5th, okay, minus 2x cubed plus x minus 10. You see, you want to determine the domain of this function. You see, as we talk about it, domain means the values that can you assign to the X. You see, basically this X is a free agent. Free agent means the domain of the X is negative infinity to positive infinity. But you check to see with this operation if there is any restriction. So what you do in this function? Your function is a mathematical machine. So this function will do addition, subtraction, multiplication. You know that x to the fifth is multiplication, x, 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 x. So whatever number you assign to the x, the machine should be able to add, subtract, and multiply. You know that there is no restriction for adding, subtracting, and multiplying the numbers. You can do it all the time. So since there is no restriction, X is a free agent. So it means the domain is all real numbers. This is the way you look into it. You see, mathematical operations would have some restriction if you divide. You cannot divide by 0. If you want to find a square root, you cannot find the square root of a negative number. But in this case, there is no restriction. So the domain of this function is going to be, we need interval notation only. The domain is negative infinity and positive infinity. Okay, or if you like, you can write d equal to the r. Okay, so basically, say that this function is defined, okay, is defined everywhere. We have a special name for this function. It's a combination of powers of x. Do you remember the name? A combination of powers of x is called what?
A polynomial?
Very good, a polynomial. You know that these are terms. You have a couple of terms together. So this is the way you explain this function for us. You are going to tell us that f is a polynomial function. Polynomial function. And so that's it. It's defined everywhere, you know, I just explain it. You don't have to. And is defined everywhere. Okay, that expression would be accepted, or you know, defined everywhere. So that's it. D is equal to the negative infinity and positive infinity, and with that. So that expression, make sure you use it. Polynomial function. Polynomials are very good source in calculus. So we are going to take this quite a lot to get these numbers. Okay, that's the first group. Any question? Give us an example of a polynomial function. Make one.
X to the second plus x plus 2.
Okay, you missed something only. What's missing?
Would be the function equals.
Yeah, of course, you have to have a function. Okay, so get something like g of x equal to h of x equal to, okay, remember you need the input and the output. Yes, very good. So a polynomial function, get used to it. You know, you start with a power and you go down. Okay, x cubed minus x plus 1 is a polynomial. So make sure that quickly you can identify it for us, a very important one. That's type 1. Any question? Type 2. Type 2 is a rational function. Okay, so start with this one. This is going to be, let's have f of x is equal to the x squared plus 3x minus 1 and divided by x minus 2. You see, since you're dividing by x, it's not a polynomial. The operation they're going to use, you see, the operation is adding, subtracting, multiplying, and dividing. So when you do dividing, this is going to be a rational function. So there is a restriction in this case, you see. So the solution is going to be, again, you think about it, your x is a free agent. Negative infinity, positive infinity. So what's the restriction for the values of the x? Restriction is the denominator cannot be 0. So you check to see for which value of x, denominator is 0. What's that number?
2.
2. So we have to exclude the 2. You see? So denominator equal to the 0, x minus 2, you see x minus 2 equal to the 0. So that gives us x equal to 2. So you got to be careful. Because if you put x equal to 2, the top is going to be a number, you see? The top, 2x squared, 3x minus 4, 10, 9, the top. 9 divided by 0, never. Okay, so you have to exclude the zeros of the denominator. So this function is defined everywhere except when x is equal to 2. But we need interval notation. Interval notation, 2 portion. So the domain is, you start from negative infinity, you go to the 2, you must use parentheses because you don't have it. If you have it, you make it bracket. If you don't have it, parentheses, union with 2 and positive infinity. That would be the domain of the function. So see, we like interval notation, okay? And so basically for your information, this is it. F is a rational function. F is a rational function and is defined everywhere except when x is equal to 2. But on the test, that's enough. You get the domain. Okay, so quickly check the operation that you have. This machine got to do the operation of the division. And the division is not possible if you want to divide by 0. Okay, that's why you exclude that numbers and then be done. Question? This may get more involved. You may have more points to exclude. Let's have another one. G of x is equal to, and G of x is equal to, this is interesting because there is something that you usually missed. So we want to warn you. Let's see. You see we have x minus 1 over x squared minus 1. Again, is a rational function. Rational function, so there is going to be a restriction. So again, the usual one is the number line. But you check to see where the denominator is going to be 0. Any suggestion?
It can't be 1.
And
-1.
1
Negative.
and negative 1. Yes, 1 and negative 1. So we have to exclude the negative 1. And we have to exclude the 1. Why? The reason is that you see you can factor. This is going to be x minus 1. And this is going to be x minus 1 times x plus 1. So you can see that you have 2 factors here. You have 2 factors that you have to exclude 2 numbers, negative 1 and 1. Now, the common mistakes is some people, they factor it, but they simplify it first. You can't do it. You see? If you want to simplify it, you must guarantee that x is not equal to 1. So you have to determine the domain of the function first. Then, if you want to simplify it. Besides, you're just interested in the domain of the function. Just make sure don't miss it. I've seen the, you will see it's similar one on the test. So don't simplify it because you just look at this one. Look at this one, you have to exclude these numbers first. You have to have the domain first. You have the domain first, then you can go and watch a movie if you like. So that is going to be the case. Don't miss it. Any question? Now what's the domain now? 3 portion. 1, 2, 3. So the domain is, you start from negative infinity, you arrive at the negative 1, parentheses, because you don't have it. Union with negative 1 and positive 1. Again, union with 1 and positive infinity. That is the domain of this function. Very popular function, and you're going to see it quite a lot. Any question? So if you want to simplify, you don't have to simplify, of course. You find the domain first, then you simplify it. Why? Because you see when you eliminate this one, some people eliminate it, And then they said the domain is defined everywhere except at x equal to -1. No, when you simplify, you already assume that this x is not equal to 1. So not equal to 1 when you simplify it. Not equal to -1 at the end, you get the same thing. But they don't usually do the same thing, okay? Don't simplify it, that's it. You factor it because you want to find the domain only. That gives you the domain of the function. Okay, you will see this one in different formats in this course. Make sure that you know that. It's not algebra, it's calculus. So you just follow the rules and find the domain of the function first. That's the second version of the rational function. Any question? There is another version of this one that we are going to use. It's a very similar but straightforward one. So let's have h of x to be equal to, let's have something like x squared minus 2x plus 7 on the top. Now we have x squared plus 9 this time. We want to find the domain of this function. Any suggestion?
Factor both.
Factor x squared plus 9. Can we factor x squared plus 9?
No.
No, we can't. So no factors. So what's the domain?
All
real numbers.
All real numbers, you see? This is the free agent. Is it a restriction? No, because x squared plus 9 is not factorable. No complex numbers, of course. So this is how we're going to explain it, you see? Just for your information, you say that the x squared plus 9 is not factorable. Not factorable. And so it's never 0. See, because in order to make it 0, you need factor. See, it's not x minus 3 times x plus 3. Some people, they miss this one. No, it's x squared plus 9. You cannot factor it. So you never be able to make it 0 because any number you pick for x, you have x squared, it's going to be positive number and a plus 9. So it's never 0. So the function is defined everywhere. Okay, so the domain of this function is going to be a negative infinity and positive infinity, or just r. And we are done. Any question? So these are going to be coming around quite a lot. You know, when we get to the next chapter, we have a notion, we call it continuity. We give it the same thing. And we ask, oh, where the function is continuous. Continuous means the graph of the function is one piece. It's the same answer, okay? Because these are going to be continuous on their domains. So this is the way you are going to sit in calculus, and not directly the domain, but there are some other things that would be related to the domain. Okay, question? Now we have another class. Let's see if we can do more today. The next one is going to be a radical function. Okay, this is it. Okay, let's start with this one. Okay, this is number 5. Radical function. You know that for the radicals, depends on the index of the radical. Because you have to check if there's going to be any restriction. You see, the solution is going to be, again, you have your free agent. You see, this is going to be a free agent. But what is going to be the restriction? The restriction is the square root. When you have the square root, the index of the radical, the number that we put here, the index of the radical is 2. 2 is even. If it's going to be 2, 4, the 4th root, the 6th root, the 8th root, etc. For all these even numbers, the inside of the radical cannot be negative. So there is a restriction over here. So I'm going to explain. You say, oh, index 2 is even. When it's even, you are in trouble. What's the restriction? And f is defined. It's going to be defined when x minus 5 is greater than or equal to the 0. cannot be negative. So it can be 0 or positive number. You solve it, that give x greater than or equal to the 5. That's it. So this is the restriction. So what's the restriction? You say it's a negative infinity to positive infinity. You have the 5, since there is equal to, we can have the 5 as a solid point greater than. You are here. So what's the domain of the function? Domain of the function is going to be 5 up, 5 and positive infinity. This is open, but this must be closed, a bracket. When there is an equality sign, you use bracket. If the equality sign is missing, you use parentheses. So this is going to be the domain of this function. Any question? We're going to have more involved, okay? And we give you next time, but I'll give you another one to see. So if this index is even, 2 for the square root, if it's going to be the 4th root, the 6th, the 8th, etc., you have to impose this condition to be positive. But if it's going to be odd, we have nothing to worry about because we can find the odd root of any number. Look at this one. You will see this function later on. It's a very popular case. You say it's got 5th root. Let's have the x cubed plus x squared minus 2. You see the index 5 is odd. When it's odd, you can have any number inside. Because the 5th root of 32, for example, is 2. The 5th root of negative 32 is negative 2. The 5th root of 0 is 0. So there is no restriction in this case. You see solution? You note that the index of this radical 5 is what? 5 is odd. When it's odd, you forget about radical. Look at the inside. What type of function is this inside? X cubed, x squared minus 2.
Polynomial.
Monomial.
Polynomials. And we know that the polynomials are defined everywhere. So index 5 is odd, and so basically this is it. The domains are negative infinity and positive infinity. Okay, if you like, G is defined everywhere. Defined everywhere. So this is 2 different cases for the radical function. If the index is going to be even, the function is defined only when the inside is positive. So there is a restriction. But if the index is odd, nothing to worry about. You forget about the radical. Look at the function. The function is a polynomial, so the polynomial is defined everywhere. Okay, that's it. We have one very important group, piecewise defined function. So we want to review that one too, and then on Friday we give you, we give you the motivation for the calculus, and we get to the first concept of calculus, which is the limit of the function. Okay, so we get to the limit on Friday morning, and then there was the breakout sections that we have. The breakout section for the limit is very good because this concept needs practice. So we try to get the practice in. We do the preliminaries in the morning, but then in your next class, the breakout sections, we bring the notion of the limits. Okay, that's it for today. Any question? So study this function. This is my expectation from for this course. We review it. We are going to question you 3 times. There is a couple of tricky ones. I give you those. Okay, so refresh your memory. Be ready for it to get to the notion of the calculus. And as I told you in this course, just think about examples all the time. There are many, many examples. Calculus is the real life, really. That's the one. So we can connect that nicely together. Okay, I have to go. I have another class. Okay, any question?
Yes, Professor. Can I see the first page again?
Thank you, Professor.
The first page.
Thank you.
Okay, have a good one. I
Thank you.
will post this recording, then you can check it again.
Professor, I also have a question for you.
Yes.
For Cengage, which do I get the unlimited or do I just get the basic
You don't need the, and
subscription?
if you want to take calculus 2, you may go with the unlimited. But
Okay,
for this course, just the first one.
okay,
I say
thank you.
just one semester would be enough. Okay. Any more question?
And you said the recording will be on career courses?
Yeah. I have back-to-back classes, so the recording would be given to probably this afternoon.
Okay, thank you.
Yeah, when I'm done, then I put
Thank
it.
you. Have a good day, Professor.
Okay, have a good one. Okay.
Thank you.
Okay, have a good one, and bye-bye.